So this, if you followed some of my previous videos, you won't be too surprised at the fact that the ocean currents carrying heat from the equator poleward, in this case in the northern hemisphere, have decreased in strength. They're carrying less heat poleward, and this all fits into the pattern of Arctic amplification. The high Arctic has warmed at least 5 to 8 times faster than the global average. The main reason for this Arctic amplification is the exponentially declining sea ice extent, the exponentially declining snow cover covering terrestrial parts of the Arctic, especially in the spring, and also the very rapid decline as shown in Jason Box's work on Greenland. The albedo has been rapidly dropping over Greenland, and in fact, a few years ago, over 90% of the surface was undergoing melt. So that adds melt ponds, and as the ice is removed, there is dirt and soot and black carbon exposed, further dropping the albedo. And this makes sense in light of the NASA study that shows that the albedo of the entire Arctic region, as determined by a series of instruments on satellites, has dropped from about 52% to 48% in the last 30 years. And I did see a study which was indicating that most of that was in the last 10 years. So because the Arctic is warming so quickly, I have talked and others have talked a lot about the jet stream slowing down and becoming wavier and causing this stuck and persistent weather. So there should be no surprise that the ocean currents are also slowing down with ramifications. Basically, the Arctic is warming because of increased solar absorption, because the whole region is darkening. So there's less need for heat transport there from the equator. There's a slowdown in the heat transport in both the atmosphere, and that's reflected in wavy jet streams and extreme weather events, and also in the oceans, which which this most recent study is showing. So this is extremely concerning because the Arctic's heating from more solar radiation. There's less heat transport up there from the equator, so therefore, the equator is warming a lot, not a lot. The extra heat at the equator is going mostly into evaporation, creating more humid conditions, but a lot of the heat is also moving southward, and it's getting down as far as Australia, and it's moving by jet streams, and it's moving by the atmospheric winds and also by the ocean currents. So it's getting down as far as Australia. Australia is baking, but it does strengthen the winds and ocean currents that circumvent Antarctica. And because of the Coriolis force being directed to the left in the southern hemisphere, it's actually pulling water and sea ice away from Antarctica in the winter. So the sea ice in Antarctica has been growing at about 1.5% per decade, and recently this Antarctic winter reached record extent, and then each summer it declines back very close to the coastline.